Hi, I'm Adrian Cockcroft. Over the years, I've given a lot of talks on microservices and cloud architectures, and there are some ideas I always wanted to illustrate with a short animated sequence. So I've worked with a visual design team to come up with a series of animations, each illustrating a specific concept. This month, I'm going to drill in a bit further to chaos architecture, which is what I think of as a cloud-native availability model. I'm going to start off by talking about my role as an architect when I was trying to figure out a lot of the technologies that we were using at Netflix. And my role wasn't to tell other people what the architecture should be. My role was really to ask awkward questions that helped other people figure out how to architect their things to meet the user needs that we were talking about. And here's one of the most interesting awkward questions. What should your system do when something fails? And a lot of people will say, I don't want it to fail. And you can go around that loop for a few times until you get them to agree that, yes, it will eventually fail. And what should it do? And there's two choices, really. You can either stop or you can carry on, maybe with reduced functionality. So let's be a bit more specific. If a permissions lookup fails, should you stop or continue? And the way to think about this is, what's the real cost of continuing? And what is this system doing? Now, in the case of Netflix, we were showing people movies, and if something went wrong internally and we couldn't figure out whether this customer was actually a current customer or a customer that used to be a customer, and maybe, because our subscriber service was not responding, it's okay to just continue, because really all you're doing is letting somebody watch a movie for free, because it's not their fault, it's our fault. So the point here is, if it's the system's fault that you can't tell whether something should happen or not, you should just probably let it happen and put the benefit onto the customer. Or if you're building a system in banking that's moving billions of dollars around, you probably want to stop rather than continue. Anyway, there's a good paper here by Pat Helland, which is a very useful way of thinking about some of these things, called Memories, Guesses, and Apologies. He was talking about database systems. A database is a thing that tries to remember something for you, then it tries to guess what you remembered, and then if it can't figure that out, it has to figure out how to apologize to you. So it's a useful paper to get you thinking a little bit differently about this. Here's another question. I like this question. Do you have a backup data center? Pretty much everyone says, yep, sure, we have a backup data center. And then the follow-up question's the hard one. How often do you actually fail over apps to it? And a few people say, yeah, pretty regularly, or once a year. A lot of other people have never failed over an app or whatever. And then even if you fail over individual apps, it's not really common to fail over the whole data center at once. If you're doing this, then congratulations, you're one of a very small number of people that have got this figured out. I call this availability theater. You invested in a huge data center at great expense so that you could fail over to it, but you're not really capable of doing that. It's a bit like taking your shoes off at the airport, which is kind of security theater. It's supposed to make people feel a little bit more safe, but it's not really making you any safer. So we have this fairy tale. Once upon a time, in theory, if everything works perfectly, we have a plan to survive the disasters we thought of in advance. And unlike a lot of fairy tales, it doesn't have a particularly happy ending because a lot of the time when something does go wrong, everything goes to hell in a handbasket, or whatever you want to call it, everything gets bad. So here's a few real examples. A SaaS vendor forgot to renew their domain name, so your domain goes offline. This means your service is offline, but also all your internal email is offline, and pretty much every internal system you do, everything you do is at yourname.com, and that name is no longer resolving. When this happened, we had the CEO of the company using Twitter to apologize to their customers for a day or two. Not a pretty sight, and something you want to avoid. So think about that. DNS is one of the areas which is the most critical for a system. How could you think about making your DNS more resilient? You might want to have an alternative domain name the system fails over to. You could test that. You could have multiple DNS providers, so if your DNS provider goes down for some reason, you can switch to another DNS provider. There's a number of things you can do here, but if you don't think about it in advance, you'll be stuck apologizing on Twitter one day. Here's something that just about everybody has had happen to them, and security certificates. Some client device, say a games console, there's a security certificate required to use it as a client device. That expires, all of a sudden that entire system goes down. Seen so many examples of this. At Netflix, we built a security monkey feature which looks for these certificates and then looks at the timestamp and then complains if any of the timestamps are coming up soon. Here's another one. Hurricane Sandy flooded areas of Jersey City and Manhattan, and entire data centers that were in basements of buildings got flooded. It's a pretty good way to test your disaster recovery failover if this happens to you. And this could be you tomorrow. So, with that slightly depressing note, let's think about what we could do about that. And here's a good quote from Chris Pinkham. He said, you can't legislate against failure, meaning you can't think about everything that could possibly go wrong and list it and say we're not going to have this happen and protect against it. There's always going to be something else that happened you didn't think of. So you should focus instead on fast detection and response. If you're really good at detecting problems and you're really fast at responding to problems, then you're going to be in good shape regardless of what the natural disasters throw at you. Let's a couple more questions. How do you know your system works at all? And how is it supposed to recover after the failure goes away? It's a big issue sometimes when you fail over to another system, and then when it fails back, it actually can cause another outage, or it can take a long time to get the system into a state where you're back into the highly available mode. There's some books you should read and papers you should look at. One of the first fallacy of distributed computing is the network is reliable. So that's a fallacy. The network, unfortunately, is not reliable. And Bayliss and Kingsbury did a great ACM paper where they went through a whole long list of cases where network was behaving in various ways or systems were slow, and you end up with the effect of an unreliable network. Peter Bayliss is a Berkeley researcher who's currently at Stanford. He's just recently moved to Stanford. And Carl Kingsbury has also done a lot of database testing. You may have heard of the Jepson testing that he's been doing. So both of them really interesting people to track down and see what they're currently talking about at conferences and whatever. Here's an interesting book. Sidney Dekker is one of the key people in this space. He wrote a book called Drift into Failure. And this is a book that talks about how when you get something going wrong, it isn't something simple that goes wrong. It's a collection of things that built up over time. And you ended up with less and less failure margin. So you get an unusual failure, that one you've never seen before, that's actually got 10 different underlying causes that all ganged up on you. If you get good at availability, then the simple things get dealt with, and you always end up with these strange drift into failure kind of problems. A lot of the failure modes he talks about are aircraft crashing and people dying in hospital. So I tell people not to read this on aircraft, but it's a very useful book for figuring out the kinds of ways that you can get into these problems and ways to think about anticipating them and not get drifting into those failures. Another really good book in this space is Release It by Michael Nygaard. The first edition of this book was actually the book I gave to a team, one of the engineering teams at Netflix, and they built the Hystrix circuit breaker system, because that's one of the patterns described in it. Second edition, lots of updates, and a really useful book on just talking about different patterns for building really reliable systems that actually work when they hit production. Overall, I think it's worth thinking about this in terms of a chaos architecture. There's 4 different layers, there's 2 different teams, and there's an attitude. So I'm going to go through this in much more detail now. Here's the bottom layer, infrastructure and services. You want to make sure you have no single point of failure. Everything you do can happen in more than one location, and you have more than one way of doing it. So that's infrastructure. But to connect that together, you need some kind of switching layer which routes your customers to those regions or to those availability zones and to your applications. And you need to replicate the data so that if something happens and you need to reroute your customers, the data they need is there when they get to it. So you need a data replication strategy, you need a traffic routing system that can switch customer traffic or incoming requests to the right place, and then they can avoid issues. And then when the world gets better and whatever it is that you're avoiding recovers, you need to switch back. So you need anti-entropy recovery. You need to put all the data back in the right way, resynchronize things that have got out of sync, and that should be as automated as you can make it. So that's the switching layer. Next layer up is applications. Unfortunately, quite a lot of applications, when they get errors or slow responses or network partitions, will just keel over and die. So you want to be able to test this. This isn't too difficult to test. Isolated microservices are fairly simple to test. It's much harder to test with a more complex monolithic application that does 100 different things. But if a microservice does one thing, it's got a relatively bounded context around it, and you can test it and be sure that it's behaving under a lot more controlled scenarios. So that's the application. The next layer up's the people. And one of the problems with people is that when they get confused, they can actually mess the system up themselves. And you get people saying, oh, let's try rebooting it, which usually is the worst thing that you could do, because the system was trying to recover, it was doing fine, it's just behaving a little strangely because underneath there's a lot of stuff going on that it's trying to recover from. So how do you train people to do the right thing when something's going wrong? And factually, there's plenty of examples of this. One of my favorite examples is the Chernobyl nuclear disaster, where an entire power station melted down. It wasn't because of a failure, it was because the operators were running through some testing. And during the testing, where they were testing some components, they got confused by what was happening. Then when things started going wrong in the rest of the reactor, they got confused by the fact that the reactor seemed to be melting down, but they didn't believe that, and basically the operators really caused the problem rather than any actual inherent failure in the system. So how do we train people? Well, one example I'm sure you're familiar with is a fire drill. It's a routine where we make everyone take the stairs and assemble in the parking lot. But when your building really is on fire, this is going to save lives, and it's going to get you out of the building because people are trained how to react. And you can go anywhere in the world, in just about any office building, and they have fire tests, and they have the same basic principles. So this is really universal, and I'm sure it's saved a huge number of lives over the years. So the real question here is, who runs the fire drill for IT? There's all these layers in the system, and we need to figure out how we're going to exercise them. So this is the name of a new team, Chaos Engineering Team. And there's a really good book from a team at Netflix that implements chaos engineering. There's several companies doing this now. Amazon Retail actually has a chaos engineering team, and other few companies in the Bay Area, but it's still a fairly new idea that's starting to spread around the world. So how does this look? The chaos engineering team is exercising all four layers here, and there's different ways of doing this. A game day is how you exercise the people layer, and this is simulated outages, maybe just getting on a phone call together, on a conference call to talk about, well, if there was an outage, do you know how to log into the right systems? Can you find the right dashboards? Does everyone know how to get on the right Slack channel or whatever they're using? There's a lot of things you need to know if you're trying to deal with an outage, and you can practice that. Even if you've got a completely fragile application which you don't want to be perturbing by running any tests against it, you should still be exercising the people to make sure that whoever's going to be on call for your system is very practiced in how to run the on-call process. The Simian Army is a set of open source tools that Netflix has created over the years. Things like Chaos Monkey, which removes individual machines to make sure that it knows how to recover from that and restart those machines. The Chaos Toolkit is an open source toolkit that you can go find on GitHub, and it's a way to describe the kinds of tests you want to do and automate capturing them. And it's got drivers for different types of services. It's got some interesting drivers for EC2, for basically doing sort of Chaos Monkey-like things, but also for Kubernetes, where it will talk to the Kubernetes API and remove your pods and things like that. CHAP is the chaos automation platform that Netflix is currently working with. It's a highly automated platform for doing hypothesis testing. And Gremlin is a product from a company, Gremlin Inc. The founder of this company worked at Amazon for a while and then worked at Netflix for a while, and now created a product which will go in and safely create very specific types of failure tests so that you can then figure out whether your system recovers from that test correctly or not. And if the system looks like it isn't recovering, then it will rapidly back out of the test and put the system back into a good mode. It's also got a lot of security features, because if you've got failure injection is something that has to be done in an extremely secure way. So there's quite a lot of productization around that. Chaos Toolkit's a little bit of a higher level open source toolkit which can drive Gremlin to go do things, but it's really more of a way to describe what you're trying to do with drivers for the different things that you might want to do with it. So that's kind of what the chaos engineering's doing, all these different layers. There's another team though that quite a few companies have called the Red Team, Security Red Team. They're doing something similar to chaos engineering, but doing it from the security angle. They're getting in to make sure that your system is secure by trying to break in. And they might do things like working at the people level by, say, leaving USB keys lying around in the cafeteria that you're not supposed to plug into your computer to train people not to do things like that, or sending spear phishing emails with links to try and get the employees to click on links, again, to train you not to do that when you get a random email from outside. All the way down to Infection Monkey, which will infect your network. This comes from a company called Guardicore that's put this out recently. Chaos Slinger is a security policy test system. Let's say you have a policy that says that none of your S3 buckets should be open to the world. Chaos Slinger will create an S3 bucket that is open readable to the world to then stand back and say, well, did your policy system catch that or not? So it's testing the systems that are there to constrain whether you can do it. And then there's a few other vendors in this space. So the attitude here is break it to make it better. And really, it's not just to make it better, it's to make it safer. So let's look at safety as a topic. This is really more of an industrial safety topic. It's not just about computers. It's about the entire way people work and the way businesses run. And software safety is really a subset of a much wider area. And Todd Conklin is one of the leaders in this area. I listened to the Pre-Accident podcast, and it's a really interesting way to get a much broader view. He occasionally has software people on, but a lot of his talk are about industrial safety or airline safety, things like that. Also, John Allspaw, who was previously the CTO of Etsy, he's been digging in this area a lot, and you can go visit the stellar.report. That's actually a URL where there's a summary of some work he did to try to figure out how to merge these two worlds. And going on to, I want to teach you a new phrase, Synoptic Eligibility. And what this really means is that in the real world, real systems are not done according to the book. You can't really write down how things actually work. That's what synoptic eligibility means. In the real world, systems are changing all the time. They have all kinds of things happening inside them. And this is the world that real humans and real computer systems live in. So you can't always predict what's going to go wrong. You have to be much more adaptable and responsive to it. And this is a phrase that is used a lot by Sidney Dekker in his most recent book, The Safety Anarchist, which I recommend everyone reads. It's a very good view about the way that safety really needs to be built into systems. And fundamentally, this is the key point. Failures are a system problem of lack of safety margin. It isn't really something with a root cause of component or human error. It's much more about the system should have been able to absorb that particular incident without causing any safety issues. So here's just a simple way to think about this as I wrap up. If you were blindfolded and you were standing on a cliff edge and you started wandering around, what would you do? You know you're on a cliff edge, so you start reaching out with your foot and testing to see if you're too close to the edge. And you start figuring out how much room you have in each dimension before you're going to fall off. So that's one approach. The other thing you could do is take off the blindfold and actually be able to see what's going on. Not always possible in computer systems to figure out just how much safety you actually have. So what we're really doing with chaos engineering is hypothesis testing. We think we've got a safety margin in a certain dimension, so we'll carefully test to be sure that we really have that margin we think we've got. And we'll do it in test at first to make sure that our hypothesis testing process is good, but we should really be running this in production because that's where the margin really matters. We really want to be doing it without causing an issue. So it's not that we're trying to break the system and have that visible to customers. We're trying to prove that the system can absorb certain types of breakage without impacting customers. So chaos testing is really about ensuring you have experienced staff, you have robust applications, you have a dependable switching fabric, and a redundant service foundation. And what we're seeing in the industry is that expensive and custom disaster recovery, data center failover, is being replaced by low-cost, portable, automated chaos engineering. So that's the story. Thanks very much, and hope to bring another one of these to you next month. Thanks.